Woohoo! Welcome back. Today we're going to be working with partial fraction decomposition. But this time we're going to work with an expression that is a little bit more complex. And we're going to talk about what to do when things get a little more jiggy. I want to take a look at this integral where I've got this rational expression or fraction where I've got x squared plus 2x minus 1 in the numerator on top, and 2x cubed plus 3x squared minus 2x in the denominator or in the bottom. And we check and see that on top, the x squared means the degree is 2, and in the denominator, the x cubed means the degree is 3. As long as the degree on top is less than the degree on the bottom, we're golden. If the degrees are equal, or if the numerator's degree is larger than the denominator's degree, then we need to use long division. So you have to do division until you get the degree on top should be less than the degree on the bottom. The degree on top has to be specifically less than the degree on the bottom. And otherwise, use long division first. And the reason for that is that the partial fraction decomposition just breaks down. It doesn't work out the way we're about to show you. So, okay, shall we go? You ready, sparkly vampire? Woohoo! Yay! So, we've made sure it's not improper. We're good. This is good. The degree on top is less than the degree on the bottom. Then we're going to factor the denominator. So I've got 2x cubed plus 3x squared minus 2x. Right off the bat, hopefully you're looking for common factors. The easiest way to factor a polynomial is with things that it has in common, single terms, otherwise monomials. And I see that there are x's running all the way through it. So I can factor out an x, and I get 2x squared plus 3x minus 2. So far, so good. Okay. Now, next up, I've got a quadratic. So you've got a couple of options. You can use the quadratic formula to factor this. You can use trial and error to factor this. You can use the AC method or the box method. There's the X method. There are a bunch of methods for factoring this. I'm just going to use trial and error because I am that old. And trial and error looks like this. You see the 2x squared, you break it into 2x and x, and then you look first to the last term there, negative 2. I've got to make up negative 2 when I multiply these two. So what are the ways to make negative 2? Well, negative 2 could be negative 2 times 1. It could be 2 times negative 1. It could be 1 times negative 2, or it could be negative 1 times 2. So I got 4 options there. And trial and error says that I should work through all of these. Through the magic of television, I actually know that it's going to be a minus 1 here and a plus 2 there. Let's double check. So I use FOIL, 2x times x, 2x times 2, negative 1 times x, negative 1 times 2. That's going to be 2x squared plus 4x minus 2. That's x times 2x squared plus 3x minus 2. I got it. Yay, yay, yay. So, in fact, this is the factorization. Okay, so it's factored. Woohoo! What does factored mean? Factored means that you get down to, in each of the factors, just an x or a prime polynomial. There are some polynomials that have degree greater than 1, but you just can't factor them any further. So this is completely factored. Woohoo! So the next thing we're going to do, and here I'm going to try to convince you, along with Sparkly Vampire, I'm going to try to convince you that we're about to do a puzzle that's actually kind of fun. Now, I understand that when it's 3 in the morning and you're doing your math homework, things stop feeling fun. But I am hoping to convince you that this is one of the more beautiful parts of math, where rather than doing, a bunch of formulas and a bunch of manipulations, you're actually getting down to pure logic. And I think that's cool. So I'm going to try to convince you that it's okay if you are unconvinced. I totally accept that. But this is what we're going to do. And again, I hope you're sitting down, because this is going to look very stressful, and it's not. It's just, mathematicians, we love making things look a little complicated. So here is our original expression from up there in the integral. So there's our initial rational expression or fraction. Okay, and what we're going to do is, this is what decomposition means: to pull something apart, right? To let it decay into its component pieces. And so I take the x and I make that one denominator. I take the 2x minus 1, I let that be the second denominator, and x plus 2 is the third. Notice that I'm taking a big clump and I'm breaking it down into the sum of 3 other fractions. What is this going to do for me? Well, yes, I know. Normally, addition is not your friend. This is one of the few times when addition is your friend, because this is a big bunch of goo, and each of these is easy to integrate. Well, I shouldn't say easy. Not as hard to integrate. How about that? And all we need to do is figure out what A, B, and C are. Now, is this allowed, and will this always work? This will always work. As long as the degree of the top is less than the degree of the bottom. That's the only thing you have to worry about. And it has to be strictly less than. If they're equal, you do have to use long division. Okay, so this is the part that I know can feel intimidating, but I think it's kind of cool. So let me show you, and then you can decide. I might be just, hallucinating. That's okay. Sparkly Vampire, you ready? I know. Sparkly Vampire loves denominators because they're very much like basements, So they're all musty and hidden and scary. And that's basically where Sparkly Vampire likes to live. So he doesn't get all sparkly in the sunshine. Ooh, there's some sunshine today. There you go. This is the math of a killer, Bella. Okay, so a over x plus b over 2x minus 1 plus c over x plus 2. What we're going to do, and this is always the same, so how much of this you write out is up to you. This process always looks the same. And so I'm going to clear fractions. And in order to do that, I am actually going to write it all out this time. But again, you may not want to write it all out. I'm going to point out that over here, we've got x squared plus 2x minus 1, and we factored this and got x times 2x minus 1 times the quantity x plus 2. Okay, that's sum a over x plus sum b over 2x minus 1 plus sum c over x plus 2. Now, I know a lot of you are like, you don't really mean to do what you're about to do. And the answer is yes, I'm absolutely going to do that. Just you wait. It's going to be very exciting. So I'm going to multiply both sides by this denominator. And you can either put it over 1 or not, as you'd like. Not everyone needs it over 1. It's understood to be over 1, so you don't have to write it in. This is the part that gets tedious. Each of these expressions here gets their own. Now, in a perfect world, I would have paper that was wide enough to do this all in one line. I don't. So I'm going to, oops. Oh, no. That should be a minus. So I'm going to have to split them up vertically. I'm really sorry about that. Let me move. Oh my goodness. Well, let me finish this up and then let's look at the mistake I made. I tried to rush through it, and I have a couple things that are mistakes up in the line above. So in each case, I'm multiplying this times each of these. So it should be multiplied, sorry about that. I wrote plus. I don't know what I'm thinking, because a plus there would really sink us. So multiplied, and then I realized I got excited about parentheses, and I put one in here that I think is not at all helpful, so I'm going to go ahead and take it out. Can you have parentheses in the denominator? Sure, but you don't need them, and so sometimes I think they're not as clear. Okay, so now let's talk about what's going over on each side. Well, on the left side, this whole thing cancels this whole thing because it's just one multiplication. So we cancel the whole thing and we get x squared plus 2x minus 1. So far, so good. Now, what's happening over on the right? Well, on the right, it's a lot more complicated. In each of these, oh, I don't have a place for you, sparkly vampire. There we go. In each of these multiplications, one term is going to cancel. So here I've got 2x minus 1 times the quantity x plus 2 times a, plus, and then in b, the 2x minus 1 cancels. So we've got x times quantity x plus 2b plus, and in the third one, the x plus 2's cancel. So we've got x times 2x minus 1c. Okay, do you see that? Now, does everybody write this all out? No. This much is kind of optional. A lot of people I know who actually do this, they leave this part out if you're not teaching it, because it's just a lot of work, a lot of paper, and it always turns out the same way. When you look here, a is over x, so you're going to multiply a times the other two terms, as we have here, and so on and so forth with b and c. Okay, so now I've got a little bit of work to do. X squared plus 2x minus 1 equals. So then I have to multiply this out. This is going to be 2x squared plus 4x minus x minus 2 times a, plus x squared plus 2x times b, pardon me, plus x, oops, sorry, nope, do you see the mistake? Yup. 2x squared minus x times c. So I can hear you all asking, really? Are we really going to be using this much blank paper? And the answer is, oh my gosh, yes. Yes, we are. This is not a moment to be saving paper, so make sure you've got lots. Okay, let me transfer this all to another page. So, come on back, Sparky Vampire. Thank you. What I've got is I've got x squared plus 2x minus 1 equals, and then a times, I'm moving these over to the other side, plus 4x minus x minus 2 plus b times x squared plus 2x plus c times 2x squared minus x. Okay. This is a times, I can combine this, 2x squared plus 3x minus 2 plus b times x squared plus 2x plus c times 2x squared minus x. Yes, I know. This is something I am sure you're all thinking, wow, isn't there a computer somewhere that could be doing this? And the answer is yes, probably. I'm sure there is. But we're going to play the game where we're on a desert island somewhere working through this. So then I've got 2ax squared plus 3ax minus 2a. So far, so good. And then I've got b x squared plus 2bx. And then I've got 2cx squared minus cx. So far, so good. Okay, and this is all equal to x squared plus 2x minus 1. At this point, I could totally understand if you're saying, wow, yes, this is such a puzzle. So the answer is, this has not been a puzzle yet, but now it's about to be a puzzle because the left side and the right side need to add together. So over on the right side, I've got 2a plus b plus 2c x squared plus 3a plus 2b, run out of room, minus c times x minus 2a, and that has to equal x squared plus 2x minus 1. So far, so good. What do you guys think? So can you see what I'm about to do? I'm about to compare the left side and the right side by saying, wait a minute, this is just x squared. This all goes together. So I need 2a plus b plus 2c to equal 1 because there's just one x squared. Okay. And then here I've got the 2x. So then I've got 3a plus 2b minus c equals 2, because these have to match up. And then I finally have to match up the constant, the minus 1, which is just the minus 2a. And this is where it's a puzzle. Now, is it maybe more than a puzzle? Yes. If you have studied matrices before, this is a matrix. And so you can use matrix manipulations. I'm not going to assume you know matrices, but again, you're always welcome to ask me or ask the tutors. I'm happy to go over it with you because using matrices to solve this is pretty sweet. But I'm going to go through and do it without matrices and show you how to do it. So we need to solve for A, B, and C. This process is exactly what mathematicians do. I mean, it really is the essence of what mathematics is someone says, well, how do we do this? And the answer is, well, let's set it up as if we've already done it and figure out what the parts have to be. So if we assume something is already done and then just work backwards to say, okay, so whatever A is and B is and C is, this has to be true, this has to be true, and this has to be true. And then we work backwards to figure out what A, B, and C are. So it's pretty cool. I kind of like this kind of logic. So I'm going to start with this bottom equation, negative 2A equals negative 1. Then we're going to divide, so A equals negative 1 over negative 2, which is 1/2. Now, with a fraction like 1/2, you can get away with writing it as 0.5. That one is your choice. I got to warn you, because fractions are involved, a lot of times you end up with fractions that aren't nice decimals. Do not do that with those. If it's 1/3 or 1/6 or 1/9 or 1/12 or 1/7, all of those, leave them as the fractions. Okay, we're off to the races now. So I've got, and I just feel like, just in case you haven't had the matrix or the systems of equations, I want to point out we've got 3 equations and what we call 3 unknowns, 3 variables. And so we do have enough information. We should be able to solve this. Okay. Let's copy down the information we have once more. I've got that A equals 1/2. And then I've got that 2A plus B plus 2C equals 1. Okay, so that means that 2 times 1/2 plus B plus 2C equals 1. 1 plus B plus 2C equals 1. B plus 2C equals 0. Okay, so we've got that bit of information. So far, so good. Okay, then we also know 3A plus 2B minus C equals 2. There we go. A is 1/2. Now, this is significantly less fun when we get something like this, but we still do it, right? 3 times 1/2 is 3/2 or 1.5. So I now have, because I got A, I have now reduced the system to a system where I've got B plus 2C equals 0, and I've got 2B minus C equals 1/2. And hopefully you guys remember, when we've got 2 equations and 2 unknowns, we can do something called elimination, or elimination by addition. And so what I'm going to do is I'm going to say, okay, what if I multiply in the bottom by 2? Then I've got B plus 2C equals 0. And then down here I've got 4B minus 2C equals 1 when I multiply each of these. And then let me write this out. So this method is called elimination, or elimination by addition. You take your 2 equations, or, well, 2 equations. Let's leave it at 2 equations. And you multiply either one of them by a number, both of them by a number. In this case, I'm just going to multiply the bottom by 2. And the thing that I notice is I get a negative 2C down here in the second equation. So when I add, I get 5B. C's cancel out and I get 1. In other words, B equals 1/5. Okay, so far so good. So then what? Well, then I can go back into one of the other equations and I can say, okay, well, if B is 1/5, I've got B plus 2C equals 0. That's 1/5 plus 2C equals 0. Now, how you do this next is up to you. If you can multiply everything by 5 to simplify it if you'd like. I'm just going to go ahead and subtract 1/5 from both sides. That's a 1 for reals. That's a 1. And I'm going to get 2C equals negative 1/2. Nope. 1/5. That was wishful thinking, wasn't it? Negative 1/5. And then I multiply both sides times 1/2. And I get C equals negative 1/10. And so you're going to ask me, great, are we done? And the answer is no, we have just started. So where are we? Well, we are now to the point where A equals 1/2, B equals 1/5, and C equals -1/10. So our initial expression, remember the one from 3 hours ago? So x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x is equal to 1/2 over x, because that's the A, plus 1/5 over 2x minus 1 plus -1/10 all over x plus 2. So this is the fraction decomposition. We've done that. Okay, woohoo. Are you guys ready for the last bit? So this is the partial fraction decomposition. And at this point, I know everyone's like, okay, now let's go take a nap because that was fun, but I'm done. And the answer is, well, we are so close. We are so close. Because what we can do is, in order to integrate x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x dx, all we have to do is integrate each of these guys. And I know they look a little awkward right now. We're going to fix that in the next, dx. Trying to get them all squished up. -1/10 all over x plus 2 dx. There we go. Phew. So what's the benefit here? Well, the benefit here is that we haven't had to do a substitution. If we tried to do a substitution, you would see that we wouldn't necessarily be able to. It wouldn't necessarily work. But since it's not a substitution, if this were a definite integral, we wouldn't have to change any of the limits, which is nice. And also, we've got 3 integrals which simply integrate to natural log. As long as there's a single x down here, we've got it. Now, this one is going to be a little bit exciting, right? Because of the 2x. So what do we need up there? We need a 2dx. So this one is going to be a little tricksy. This one, natural log of x, right? I'm going to skip over this one for right now. So let's talk about what happens. Once you get the hang of it, you kind of memorize what happens, so it's not as difficult. This one, since it's just a single x there, it's natural log of x plus 2. Now, you can put your c in now, but since I have one integral that's not done yet, I'm going to leave that. That's going to carry all of the work for the constant. Okay, we are in the home stretch. So, what about the integral of dx over 2x minus 1? Okay, let's talk about that. So again, I've got 1/2 times the natural log of x, absolute value of x, plus 1/5 dx over 2x minus 1, and then minus 1/10 natural log of x plus 2 inside absolute value. So why is this one extra spicy? This one is extra spicy because there's a 2 in front of the x. If you have a constant in front of the x, which you frequently will, let's look at what that would actually be to integrate it. So this one, we're going to have to do a little substitution. Once I show you how it's done, though, I think you're going to see that you could probably do this in your head without having to do the substitution, perhaps. So if I do a u substitution, let u equal 2x minus 1, then du is 2dx. So that means du divided by 2 is dx. So I'm going to get 1/5. Dx is du over 2 all over u, which is 1/5. Let me pull out that 1/2 du over u. So it ends up being 1/10 du over u, which is equal to 1/10 times the natural log of u, which is just 1/10 times the natural log. I know I'm fighting the sunshine. The sunshine comes in and suddenly you guys can't do math anymore. Yeah, that's not going to work. I'll just try to go quickly so that you can see what's happening. How's that? Better a little bit. So what was u? U was up here 2x minus 1. Okay, so that's what happens. So notice that this extra little 2 down here is going to get translated into an extra 1/2. So my final answer is going to be the 1/2 natural log of the absolute value of x plus 1/10 natural log of the absolute value of 2x minus 1 minus 1/10 natural log times the absolute value of x plus 2. And then what is the last thing I need to do? Right here, plus c plus c plus c. And we've done it. You guys are amazing. You guys are awesome. I have too much light on me now, so I'm going to have to take a break from videos. But in the next video, we're going to talk about what happens when bad things happen. So what happens when the degree isn't appropriate and we do have to do the full division and then the partial fraction decomposition. And I will show you what to do that then in that video. For now, you guys are amazing and incredible. And I just think you're wonderful. And I am so glad you're here with me. And I hope this made sense. And if it didn't, please reach out. Reach out to tutors, reach out to me. Let us help you understand, because this stuff is so understandable. It just, we need to figure out just the perfect way to say it so that it makes sense to you. And I would love that challenge, and the tutors would as well. So give us a chance to say it a million different ways until we come up with the way that gives you that light bulb moment. And until we do, know that you're amazing and incredible and so very smart. And I am so proud of you for making it through a 33-minute video on calculus. Yet again, you guys are incredible. So go out, touch some grass, breathe in some air, and I will talk to you in the next video. Math on, woohoo.